day 3 of the Pythagorean Theorem. We're getting close to wrapping up chapter 12. I will be back tomorrow, so I hope you guys have been awesome for Miss Monir. She is great, so I hope you've treated her with respect, and I have a nice report to come back to tomorrow. Today's lesson, we're going to be trying to find out if some triangles that we have are actually right triangles or not by using the Pythagorean Theorem. Alright? Now, before we get into that, a little lesson on life. You guys have probably realized this by now, but there's a lot of posers out there in the world. A lot of posers. You guys have probably seen them in middle school. People trying to be someone that they're not, whether it's to try and be cool or I don't know, try and just be popular. Whatever it is, there's some posers out there. People like to act differently than who they really are, all right? And the lesson kind of goes with this. You should just be yourself, all right? Because we're going to see what happens when we have some posers today. We're going to have some poser triangles. Yes, it just doesn't stop in middle school or high school or even after that. There are shapes that also like to try and be posers too. Yeah, believe it or not, there are shapes out there in this world that really want to try and be and act like a different kind of shape than they truly are. And for some reason, I don't know why this is, there are a lot of triangles who would really like to be right triangles. For whatever reason. I mean, it's the craziest thing. You have all these triangles that for some reason they would just love to have a 90-degree angle, all right? But not all triangles can be right triangles. And today, unfortunately, we're going to meet some posers, some triangles that are going to try to be right triangles, and we're going to find out that they're not. We're going to use the Pythagorean Theorem to test this out. All right, so let's take a look at our first couple triangles we have. We have triangles number 1 and triangle number 2. We're going to see if either one of these are posers, if they're trying to be a right triangle, or if they actually are a right triangle. All right, so you're going to have some problems like this in your book where they're going to give you the measurements for a triangle, and they list them just like this. And it actually goes in order with the Pythagorean Theorem with the A, B, and C. Okay, so like the first number you come across, this will be side A. The second number that you come across will be side B. And this third number will be side C. All right, it's just going to follow in order, so you don't have to try and guess which one is A, which one's B, which one's C. Okay, so we usually don't see the pictures of these poser triangles. We just have their measurements. So we have to try and verify if they are a right triangle or if they're going to be a poser. All right, so let's check this out. We're going to use the Pythagorean Theorem, which is, in case you forgot, a squared plus b squared equals c squared. All right, so we're going to use that. We're going to take these numbers and fit them into the Pythagorean Theorem to see if this is actually a true right triangle. And this is what it's going to look like. So since 4 is A, we're going to take 4 squared plus 5 squared and see if that will equal 7 squared. All right, so we're just going to do some math and see what we come up with. So we get 16 when we take 4 to the power of 2, and then we'll get 25, and 7 to the power of 2 is 49. Okay, so next step, we're just going to add up 16 and 25, and that would get us 41, which does not equal 49. Uh-oh. This is bad. We just found our first poser triangle, a triangle that was trying to be a right triangle but just couldn't make it happen. All right, we have our first poser. Because 41 does not equal 49, So this triangle, it is a triangle. It is not a right triangle. So we're going to label this no. All right. It is a triangle, but it's just not a right triangle. All right. Let's check out our next triangle to see if this is actually a poser or if it is a true right triangle. We're going to set this up the same way. This is A, this is B, and this one is C. And then we're just going to put that together. So we have 85 to the power of 2 plus 204 to the power of 2. And we're going to see if that will equal 221 to the power of 2. All right? So we start doing the math on that. And since I worked this out ahead of time for you guys, 85 to the power of 2 is 7,225 plus 204 would come out to 41,616. And 221 to the power of 2 is 48,841. All right? So we're just going to add these two together. And when we do that, we actually get 48,841. And that equals 48,841. OMG, we actually have a right triangle here, a true right triangle. No posers here. This is a bona fide, genuine right triangle. All right, so that's an example of what it would look like if we do actually have a right triangle. Let's check out part B. This time we're just going to do the same thing. Same exact thing we did up above, but this time we are going to have some triangles in a word problem. All right, and this word problem, we have a blueprint for a new triangular playground. Shows that the sides measure 480 feet, 140 feet, and 500 feet. Is the playground in the shape of a right triangle? All right, that's what we want to decide if this playground is going to be a right triangle or not. These numbers follow the same as they did above, where the first one is going to be A, the second one will be B, and the third one will be C. That's just how they write out triangles to make it easier for us. And we're going to put that into the Pythagorean Theorem. So we have 480 to the power of 2 plus 140 to the power of 2 equals 500 to the power of 2. All right, so we're going to see if that actually comes out and if it's true. So 480 to the power of 2, that's going to get us 230,400 plus 19,600, and that'll equal 250,000. All right, we're going to see if that does actually equal that. So if we add these two together, we do actually get 250,000, which that's equal to 250,000. So this playground is actually going to be a right triangle. All right, so this is another genuine right triangle, no posers here. And that is about the end of our lesson for today. And even a bigger lesson for today that goes above and beyond math is, just like these triangles, don't try and be a poser. Don't try and be somebody that you're not, because eventually somebody's going to find out, just like we found out about these triangles. And you guys shouldn't try and be someone that you're not, because each of you are truly awesome. As I've gotten to know you guys the last 3 quarters, each person in this room, every person in this class, all right, has something genuine to offer. And you shouldn't change a thing about yourself. And it is a privilege for me to get to work with you guys and know the special individuals that each one of you are. So with that, let's open up our books. Let's get started on 12.2 and try and find some of those poser triangles. Good luck.
1, 2, 3.